you said. I did engineering, BSc electrical at UZ from 2005. One is to install a system. They should know that there must be a controller somewhere, somehow, whether it's inside the inverter or it's a standalone module. What it does is it helps prevent overcharging of your batteries. Because when you put your solar panels on the rooftop, as long as there's light, the solar panels are going to be pumping in energy to the battery, right? So they suppose, if the batteries are full, there's supposed to be a mechanism to say, hey, panels, please stop.
Right.
Otherwise, I'm okay. So that module is the charge controller. So it can be either inside the inverter or it can be outside. And also, these days, everyone knows that possibly we are getting our main supplies, which is during the night. So for use next day, we can also use the same batteries to store that energy. So these inverters, they are now coming with also a charging capability. What I mean by that is, when ZESA comes back, the inverter has got a capability also to charge your batteries for use next day, right? So that is what I could say is the brief background about a solar system, right? So what is mainly important is to understand the resource dynamics. That will then lead to understanding the topic of how then to manage it. So the resource dynamics is simply, we are saying we are using radiation from the sun, and this radiation passes through some space, and this space could have obstructions, just like there could be cloud cover, it could be raining. So when you do understand that you are using light, when you don't see enough light out there, then you should know that you got a challenge in terms of your system. It's almost like you are driving a car and it's giving you a red or an amber on the petrol.
Sure.
You know that you're supposed to reduce speed. Yeah. Something like that.
So that's a really, really good background in helping us understand how this process actually works. And a few questions come up as a result of it. You mentioned that when we're talking about the systems that we're installing in our homes, what we are trying to capture is the light from the sun and not necessarily the heat from the sun. So we're just looking out the window now at the moment. It's cloudy, but we do have light coming from the sun. So today, with the cloud cover, does that affect in any way the radiation that is coming to the panel?
It does. It does to a greater extent, actually, because what this radiation, the one that is mostly effective is the one that is just coming direct from the sun to the panel, right? When it is like today, when there's cloud cover like today, that component of radiation is not there, right? However, what we remain with is that light that is coming through, not directly, but it's scattering through. It's trying
to make its way, even though there's obstructions.
Yes. So that component is the one that then the solar panel will eventually use to convert that light into energy.
Right.
So roughly I could say the percentage reduction is between 10 to 20%.
Okay.
So we would have lost 80%.
Right.
So if you've got 1,000 watts panels, it means when it's like this now, you probably just going to get 10% of that, which is 100 watts. So you'll be like, just see yourself as someone who has got 100 watts panel, even though you have that big one, the big one. Yes.
Makes a lot of sense. You mentioned, of course, that once energy is taken in through the panels, and then it goes through an inverter, which converts it into the energy that we need to use our appliances and so on. Can this be done in real time, in the sense that when the sun is shining, you're getting the light, it's going through the panel straight into our inverter? Can you use that energy instantly, or does it need to first spend some time being stored? Or can you explain that process?
Okay. Yeah. The energy can be used, actually, in most cases, it is used instantaneously.
Right.
But still, it passes through that route. It comes from the panel. From the panel, it goes to the battery or to the charge controller, and then from the battery or to the charge controller, it goes to the inverter, where it is inverted to AC. Now, there are a few people who can choose to use DC loads. There are DC lights. What I mean by that is, if you remember, if you go like Omusha, you see torch.
Yeah.
A torch. That light is using DC. Or car lights, right? They are using DC. So there are DC loads that one can use. There are DC ions, actually. This is very new here. People have asked a lot of questions about ironing. There are DC ions also, which you can connect to the charge controller if it has got an output for DC. So it's possible. Actually, that is the normal way. That energy is used instantaneously. Once you've got your panels on top, you switch on your lights, it's instantaneously. What then goes to the battery is the remainder of what the panels are producing and what your load, because suppose you have your fridges, a fridge is usually on throughout.
Yeah.
So if you are using a solar system completely off grid, what it means is during the day that fridge is demanding energy throughout. So it is the remainder between what the fridge is demanding and what the panels are producing that would then go to charge the battery.
Right.
Yeah.
So we talked about the fact that the panels are the ones that are capturing this energy. Talk a little bit about the installation of these. Is it just you put it on any part of the home, facing any? Are there any optimum spaces where you need to put it? Mm.
Yeah. So that is actually a great question, because we've seen that there's a lot of tricking people around. People. This is new to us.
Sure.
So people don't really know, but the specifics that are supposed to be procedures. If I could start with solar panels. Remember that I did not mention anything about heat. The heat actually reduces performance of the panel.
Right.
It actually does act in an opposite direction. It reduces its efficiency. When a solar panel is made, you check behind every solar panel, you will see that it has got a specification sheet that is written. That is standard temperature conditions. So in other words, for us to say we've got a 300 watt solar panel, it is 300 watts only at 25 degrees. So if temperature is around 40, 50, that means it's not going to be giving us 300 watts.
Right.
Right. So how to then help it not to heat up? It's supposed to be elevated a bit from the roof.
Right.
Because that way it's going to have free air circulation around it to cool it down. 1, 2, it's not going to conduct, the frame is not going to conduct heat from the tiles.
So when you say it should be elevated a little bit, by how much should it be elevated?
Dive in anything from 8 centimeters.
Okay.
Yeah.
So
not too high, because then it would make the roof appear very funny.
Okay.
Yeah,
Okay.
yeah.
So just a little bit of space
Just a
between
little
those
bit of
tiles,
space, yes,
and the panel.
Just to cut the conductive part.
Okay.
Yeah.
So in terms of, does it need to face any direction, for
Yes,
example? Yeah.
Yes. So having elevated it, there is what is called a tilt angle, right? That is the slope, right? This slope, just to give a guideline, it's supposed to be equal to the latitude of that place.
Okay.
Where you're installing it.
So break that down for us. What does that mean?
Latitude.
Yeah.
Latitude is geography now.
Right. We're going there. Engineer, take us to geography now.
Okay. Right. Latitude is like if you go to any place,
yeah,
you find coordinates of that place that define that place in the space. Right? Every place has got a latitude and a longitude.
Yeah.
Right? So it is the latitude angle that should then be equal to the slope. Right? You elevate it through that angle.
Right.
Right? That is the slope. Because why do we have to elevate it like that? Because for us we have a maximum, right? When this solar panel is done in the lab, is being made, for them to size it or give it a space to say this is a 300 watt solar panel, they would have used the radiation that is going to heat it at normal or at 90 degrees.
Right.
Right? So by elevating it, we're trying to make the radiation hit the surface of that solar panel at 90 degrees. Right? That's that. So for any other place, anywhere in the world, the tilt angle should be equal to the latitude of the location in place. Latitudes do differ because
Right.
yes.
All right. So
then,
it's yeah. Mhm.
then where should it face? That is called the well, I don't know how to say this one, but it's called the azimuth. In simple, they should face north
Right.
if we are in the southern hemisphere. But if you've got listeners outside the southern hemisphere, then those panels should face south.
South. Okay.
Yes.
Okay.
Exactly that.
So some technical things here, and the reason why I'm going into detail around these technical issues is because a lot of us have now started relying on solar energy to supplement the supply that we get from our energy distributor here in the country. And with the resource being very limited, a lot of people have ventured into it. Let's talk. I mean, you work in this sector as well, as a business person in this sector. Do you think we have a level of understanding that's enough when we come in as people who are purchasing these systems? Do we have a lot of knowledge, or are we relying quite heavily on service providers to be able to explain it to us?
No, the knowledge is still very limited. What I've seen around is people don't really know about this. For instance, people could be attracted to the size of the battery as it looks. They would say, I've got a very big battery, right? But this battery is second hand and it's old, but it looks big in the eyes.
Yeah.
So they'll say, I've got a very big battery, but inside the battery there's nothing.
Right.
So they're going to buy that at a very high cost, right? Sometimes the cost which is even higher than purchasing a new battery, but because it looks very big, people would think that it is better to have that one.
Yeah.
So when they go home now, they put it on the system. 20 minutes down the line, the lights are off. You see. So that is a challenge. So I can say for now, people are entirely relying on salespeople. So who can actually get some things into their stock and say this doesn't work?
Right.
Everyone will say this is perfect. This is perfect. So where do we have things that are defective?
Yeah.
You see. So it's a challenge for now because it is the person that is selling that is also dabbling as the technical expert in that.
Yeah.
Yeah, we've seen that, and we've done a lot of reinstallations where things would have gone wrong. Sometimes it's the sizing that is not matching the load. Sometimes it's the cabling that is not good size and it's burning up. So a lot of things have been happening, and I am sure that there is no control to that because the buyer has got an option to buy where they feel or the way they want to buy from.
Yeah.
Yeah. So at the end, it's not going to. And some people don't say if they've got problems. Some people prefer to stay with their own problems. They don't talk. They don't say anything. Like everything is okay, but deep down they know that, hey, I just lost $2,000.
I lost a lot of money.
Yeah.
An interesting question comes in here, and this mirrors, I think, a sentiment that a lot of people have, or a concern that a lot of people have. Someone says, is there any difference in these panels? Let's say one is made in China, another one is made in South Africa, and same applies to the batteries as well. We've often heard that if you get panels that come from Canada, for example, they're of the highest grade compared to others. So let's talk about whether that's a real thing.
The brands. Yes, it just like any other appliance. For example, I could give you an example of a phone. You buy a phone that is written 8 gig memory. You just take 2 photos and that phone tells you not enough memory. But what is written on it is 8 gig. You would expect to put videos, you would expect to put a lot of stuff, books, whatever. But just 2 photos, the memory is full. So that still happens. Now, but because we are not yet that advanced, I would say it is very hard to tell. Because what we are simply relying on is what is written as the specification of that panel. So what could actually be the technical people, the installers, could help on in this regard. So in other words, I'm saying, if you want to purchase a system, just get someone who is technical about it to at least help you, right? go with that person, at least understand what is it that you're buying, right? Because I have seen people buying car batteries to then use as on solar systems. That doesn't work because the design of the batteries is totally different.
Sure.
So I would not say batteries that are made in China, they are bad, or batteries that are made, solar panels that are made in China, they are bad, or those are made in Canada, they are the best. I would not say that, because you could have a Canadian company that is based in China or vice versa. There was a time I was in the US. They actually told me that we do not have local industries per se. What we have is industries that are coming from other countries to come and do their business here. Right. So you see ABB, you see a lot of big companies based in the US. So if it's just an issue of probably checking what you're buying. Otherwise, you would recall that long back would have almost everything written made in China, but they were very good. Yeah. So I think it's just you can also have a company that is based in China, but not doing so good. Another one doing so good. So, but so far, what I have seen is, yes, some panels they do better than others, but to tell is really a challenge for now.
So essentially, people do need to do their homework and then use an expert in the industry to give them advice around this. We're talking about applying solar energy management techniques with engineer John Murira, and we spent a little bit of time helping you understand how this process actually works, what sort of energy we're taking, how it's extracted, how it's stored, and how we can use it in the home. So when a person says they're getting a solar system, they intend to get a solar system, we're going back a little bit. Explain to our listeners what they're actually getting in the system, what comes in that package, and what should you have there to make sure you're starting on the right footing.
Okay. The first thing, however, is not about getting the solar system.
Right.
The first question that one should answer is, what do I need it for?
Right.
What appliances do you want to power using solar? Right. I would say average homes, average people, they are using it for entertainment and fridges, of which I also think that is so far where we can go. Right. Based on the limitations of storage and the limitations of a radiation, and you see. So the first thing is, how many TVs do you have? How many fridges do you have? Do you have a bowl? Or what size is it? It's not just about saying, I've got a bowl. Right. What is the size? Now it matters, right? You really need, now figures matter. You really need to know your TV, how many TVs, how many lights. Some people just say, I want to use it to power lights and TV, right? How many lights? Is it 100 lights? Is it 10? It all differs now. Right. So when you answer that then if you give that information to your technical expert, then that person will then be able to size the system. By sizing the system, I'm simply saying the person will be able to tell how many panels are required, how many batteries are required, what size of the inverter to give you capacity. The inverter gives you capacity to power that load. So to start with a simple package, to light up, for example, let me just say to light up a TV and lights, would say you need panels, you need a charge controller. This charge controller, depending on the type of inverter that you have bought, it could be inside the inverter or it could be a standalone module. You need batteries, and then you need the inverter. Those are the components that you need. And most importantly, also, you need the right size and the right type of the cable. Right. Because otherwise, if you put wrong cables there, what you lose in the cables could be equivalent to just something that could be used to power some lights. Right, so that's quite a high loss, because you could be using it for other things. If you use wrong cables, then you have a high resistive loss there. How important is it for users of these systems to have the right person doing the installation, and is it always a good idea to use someone from the shop that you actually made the purchase? Right. I could be working in a shop, so I could have the knowledge, what is, in other words, what is important to have the person that has got the knowledge. Right. At least they should be knowledgeable, because they are going to be interfacing. A lot of people have lost inverters because these inverters, they are hybrid. They're going to be interfacing with ZESA. So a lot of people have lost their inverters. The moment ZESA comes, it sees the inverter as the load, and then it's trying to power it.
I see.
And then it burns up. Yeah. So you need the person that does understand, or maybe people that do understand how these systems work, how it's going to interface with this, going to collect the energy, because you can buy 10 panels, they face wrong direction, wrong tilt angle. It's like
right.
So it doesn't work. Yeah. So you definitely need people that are technical to do the job. Yeah.
Okay, let's take a call. Good morning, you're through to Capitalk FM.
Morning, Ben, how are you?
Well, thank you, Godfrey. Give us a contribution.
My quick contribution, it's not putting out one or inverter. One or connect a wachoga. I was one or go to connect my inverter. Because you all that you to try straight capeniga. It's a good soga. My inverter cannot connect a friend as a diagonal. My inverter is my Shidaro. Why? Because the common Munesa it does repeat some connector. So it will come to be what? A problem now whereby panel lighting as nothing for my chichi, someone lighting, it's like that. But I'm a jet of the Akuyaga. I don't know any more to work around this. But my vetas, my gingy, and Fanaku, let me tell you, like Bitron, for example, in a programmer, which my jet at Awuya, in a motor wonder, in a holder, in a Stamazon release. You understand?
Yep.
So I think problem is which you haven't got this let's talk about saying better and don't go to vita. Then you zero way sleeper.
Okay. Thanks for that contribution. So Godfrey raises an interesting point around the rainy weather. Is the weather right now, in terms of, aside from the fact that it's cloudy and so on, is it affecting the performance of
in terms of what he has raised? It is a valid point, because that's why I said you need the right people. Okay. I'm thinking that by saying technical person that does understand, we would then understand everything.
Yeah.
Right. When you put solar panels on top, right, they are supposed to be earthed. Right. So
okay.
Although I am sure it is beyond. Coming through the inverter that first goes.
All right.
Or solar pumping system, it is that pump
that goes. And that's what we're seeing a lot of.
Yeah. So it's simply because the panels would not be, the frame is supposed to be connected to earth. Actually, the solar panels have got that sign. Unfortunately, don't know that sign. But there's an indication that, in earth is most solar panels, they've got a symbol on the frame that shows you're supposed to connect to earth. There is no, it's different from a 3-pin plug, for example, that does 3 pins. So
you know that earth is there.
There is supposed to be a cable there. Even if you don't know it, you know that something was supposed to go there. But on the panel, it's black and red coming out of the panel, or positive and negative coming out of the panel. Those are just cables.
Yeah.
2 of them. So the boy just take those 2 and connect it.
Straight.
But on the frame, there is a symbol that you're supposed to then connect it on that.
Okay, so we've got a couple of minutes left now. We've understood how the system is installed, the components that you need, who you should use to connect the system, and also trying to manage what your needs are. Once I've had the system installed, my hypothetical system has been earthed, everything is safe. What are some of the things that we can do to make sure we're managing the system well and the energy that we're getting from it in the last couple of minutes?
Right. So that is actually more important than buying the system.
Right.
Because you can never manage to install, and it's just like, for example, you're taking the water, right? Kids are filling the tap, and you, as the parent, you're saying, I'm not worried. My kids should play with that tap, whatever they want. I should keep on refilling the tank.
Right.
Well, you might have resources to fill the tank, fine, but the bowl may dry up. Then you're done. So in other words, the management of that system is equally important, right? So I would think that the appliances themselves, they do matter. You cannot put a floodlight on a solar system and expect to have the same performance as the one that has got an energy saver light. So in other words, I'm saying, when we do purchase our appliances, let's be aware, or let's be conscious of what is it that they are going to consume. Let's try to have energy saver components, right? And then we have to be aware of the weather patterns, because remember, initially we said the source of this energy is the sun. So when you wake up and you see it's raining, it's cloudy, just know that today I might have problems with my energy, right? I might not have enough. So what do? You don't switch on a television when it's not being watched. You don't leave perimeter lights on when they are not being used. When it's during the day, you don't. You see. So it is that management that really does a lot of tricks. You would realize that if you do that, it would be like you have added another battery or other battery, right? And let's also avoid system or components or appliances that could shock the system, especially the battery. The battery is very much sensitive to shock. What I mean by that is just throwing a very big load to it. People have asked it, can I put an iron? Can I put a microwave? If, for example, a system is big, like a 5 kVA system, for example, you find that a microwave could be ranging from 2,500 watts to 3,000 watts. That is very big, because just a microwave could fill up the capacity that a 5 kVA inverter is producing. Yeah. So putting that onto the inverter might be okay with that, but the battery
will struggle.
The current that you're then going to draw from the battery it will come as a shock, because maybe I didn't want to go deeper into the battery chemistry, but what is producing that current from the battery is a series of chemical reactions. So every reaction has got a time that is supposed to be completed in this time. So you're trying to force that reaction to happen. You see.
Right. So many points that you have to consider once you have the system installed. And I guess we can go into a little bit more detail in another discussion. Engineer John Murera, thank you so much for joining us today and helping us understand the use of solar, particularly on the side of installing it into our properties. Have a great day.
Thank you.
That marks the end of the program for us. Thank you so much for joining us on Startup Capital, Harare's Wake Up Call. Join us again tomorrow morning at 6. You're listening to Capitalk 100.4 FM, Harare's Heartbeat. The time now is 9 o'clock. It's time for the news with Patience Chiwa.
News on Capitalk 100.4 FM.